Mesdames et Messieurs, ladies and gentlemen, I'm very pleased to be here again, 10 years since the previous International Day. As Phil said, I'm a forest manager primarily, and over the last 30 years, myself, Phil, and several colleagues have been the main pioneers of the introduction of irregular silviculture into England and Wales. And our discovery of Futaie in 2005 was probably the most important event in developing that practice and also providing the guidance that we needed to begin to collect data on which to underpin that practice. Get this to work. The network in England and Wales is not large. It now comprises 4 reference stands in England and 3 in Wales. It's worth saying we have been quite involved with the establishment of the network in Ireland, and Paddy Purser is going to talk to you about that later. The major constraint on the development of the network in England and Wales is that it relies solely, more or less entirely on private funding. And that means that it's down to the private sector and interested owners. But 5 years ago, we created the Irregular Silviculture Network, which was set up really to be an English-speaking interface with the AFI. It's a part of the AFI, and it's meant to service the AFI network in England, Wales, and Ireland. But we're also obviously also trying to develop the development of the reports into English. But the setting up the ISN has also been concerned with another significant issue. One important distinction between the UK, Ireland, and the continent is the almost complete lack of tradition in UK and Ireland to the collection to measuring structure and timber increment. It's not something that's done at all, and there is an almost complete lack of data on the link between structure and increment at stand level. Now, as we began to develop our own practice, we clearly had to do some of this, and initially we used the method to control. But of course, once we found Futaie, we were involved with setting up some full Futaie sites, but then we became aware of the abbreviated protocol which Max had developed, and he's very kindly allowed us to develop this for our own use, because the encouragement of more basic measurements of stand structure and stand performance is in stands that are under conversion to irregularity in the UK and Ireland. It's a really major aim of the ISN, and it's a really important aspect of what we're doing. Now, most of these we'll call them ISN stands now, but they're abbreviated AFI protocols. Mostly they're used as local research stands, stands selected on particular estates to provide stand management on particular subjects, very similar to the way in which the network developed in the AFI. We've got about 35 of these operating on estates that myself and my colleagues manage. Sometimes we also use them at the forest inventory sale. So this is to develop data on the whole of a forest estate. So this is whole forest parameters, including calculation of carbon sequestration. Now, although the AFI network is relatively limited, the estates, the big estates and that have AFI stands have become a focus for wider research into various aspects of irregular silviculture. And I thought it might be interesting just to quickly give you an idea of 2 current PhDs which are running on one of these estates into 2 rather interesting aspects. So the first PhD, which is the fieldwork's finished, and the data is being processed. It'll be written up in the next year. This is to do with the link between forest management, genetics, and the approach to ash dieback, Kalara. Now, the estate that I'm talking about, the Rushmore estate, it's about 4,000 hectares of land, 800 hectares of forest, of which 500 hectares have a significant proportion of ash. It's on a good site for ash, on a chalk-based site, and it has very high biodiversity value. Now, you are probably aware that the Danish scientists have identified a number of genetic markers to ash dieback tolerance. And a scientist in England, Dr. Andrea Harper of York University, she developed this technique, and she undertook an experiment about 5 years ago on a provenance stand, so a stand of young oak ash trees that had been drawn together from various origins to test their timber quality. And it was situated in the middle of England, and it got overtaken by ash dieback. So what she did was, it was about 50 trees. These are all the dots here. She tested them all for these genetic markers, and she predicted the amount of damage from the genetic tolerance alone, and that's the one on the bottom, predicted damage. So this is the predicted damage using just the genetic markers, and then up the y-axis, we've got the actual observed damage. Now, what this shows is that for the trees with high degrees of tolerance, so this is the area, I'm not sure that's working. Yes, there we go. So these trees down here, which had high levels of genetic tolerance, they also had very high, low levels of damage. But once you moved away from these first 7 or 8 trees, the data went everywhere. And clearly there's other significant variables going on. It's not just about genetics, it's also about something else. And one particular idea, which is not really very surprising, is that the individual vitality of the tree before ash dieback occurs may be significant. Now, we also considered that the stand structure may be also important. The degree of airflow, the relationship between the amount of understory and overstory, these may also be part of the story. So the hypothesis of the PhD was this, that ash dieback will be less severe in vigorous trees which have a degree of genetic tolerance and which are located within stands of a particular stand structure. That's the hypothesis. Saying another way, the question is, can you actually manage the stands to affect the resilience of the stand to ash dieback and to reduce the damage? Now, it's worth saying that politically in the UK, this is quite controversial. Most people in the UK want to pretend that it's an act of God and there's nothing we can do about it. It all came over from the continent originally, apparently, in a great cloud. But then they realised that wasn't actually true. But still, there's a big reluctance, really, to see management as a potential way of ameliorating the effects of ash dieback. So the PhD involved the genetic testing of 600 individual ash trees. We've got a wide variety of stand types and structural diversity across these 500 hectares. Now, that's very challenging. This is RNA markers, not DNA markers. The Danes did the work in controlled conditions in a polytunnel. We've done it in the field, which is really challenging, but we're getting there. We've got some interesting results. So obviously, a lot of environmental factors were measured. The individual dendrological information for each tree was measured, the stand structures, soil, weather. And then we did a score over 3 years of the damage to the individual trees. And this is just the summary of that. So this is 3 years of damage scores. The more red, the more damaged, the more green, the less. And you can see also how it relates geographically to the different areas in which these sample trees were located. So one thing as I say, this will be written up in full later on this year. One thing we did manage to do was to actually create chronograms of individual trees, and this is just to give you an idea of the variability. The first thing we found, which I knew anyway, is that there is very significant variation in the degree of damage between these trees. Remember, we've got quite a lot of trees with a good thinning history, with big crowns, with relatively low growing stocks. A lot of this estate is developing into a regular high forest. It's not overstocked. But for example, the one on the left is an example of a tree. I don't understand the genetic side of it all. It's very, very complicated. However, I was told that this is what they're looking for. They're looking for this signature here compared to this signature here. That is the signature of the marker, which is regarded as being showing high tolerance. This is a marker of no tolerance at all. Now, with regard to these two individual trees, obviously it works that they very clearly have different genetic tolerance to the disease. We've at the moment only just really started to produce some basic relationships. Clearly, diameter is important, crown size is important, which again suggests that vitality is a key element. So within the next 6 months, we would hope to have some multifactorial models and give some idea of the contribution of genetics and tree vitality, and therefore management, the role of management in trying to ameliorate this disease. Okay, so that's one. The other one, which is actually on the same estate, is to do with the whole issue of broadleaf woodlands in the south of England and biodiversity. Over the last 25 years, much attention has been given from the government and from the NGOs, the nature conservation NGOs, on the relatively limited areas that are left, which are now surviving natural woodland that haven't been subjected to various plantation events. And these are seen as a very important reservoir for nature conservation richness within a general countryside in which the biodiversity is declining at a very strong, fast rate. This estate, which I've managed since 1985, is one of the largest areas left, and it has a very high level of designation. So in this case, it's a private owner who is more or less required to deliver a significant amount of biodiversity, but has to do it in some sort of financially viable way. Now, there's very little systematically managed irregular high forest in native broadleaves. In fact, most of them have been developed by me and a couple of other people. But we have got some in this forest. Where we do have these stands that are developing into high forest, quite a lot of them are at relatively early stages of development. Now, these estates traditionally have been I can say traditionally these were managed as coppice, taillis, and probably for at least 1,000 years on this estate, well, more than that, on this estate, probably 1,500 years at least, there's been a continuous use of this technique. But in the 18th and 19th century, the taillis of southern England developed into a very specialist form, dominated by hazel, noisetier, and bouleau, and birch. And so not at all like the taillis that you're used to. And this is what it looks like. Virtually no trees. And the craft, we could spend a whole day talking about the economy that sat behind it. These are particular products that were originally linked to the agricultural system in the area. The economic system, though, that underpinned this ceased to exist before the Second World War. So there's no real financial viability in this approach at all. And in fact, the area that's managed like this now is very small. However, it's worth saying that the people who are sitting in the government nature conservation bodies, they have no real concept of the management of high forest, and in the last 20 years, the prescription they've often wanted to fall back on is go back to the tradition. So they try to encourage people to go back to this traditional form of management, although the forests have changed. You need a particular structure to make them work, even if the economics works, though the structures have changed over time. Of course, what this means is because most of the traditional methods don't make money, people don't understand how to manage the high forest. That's mostly what happens, so nothing. And again, there's a significant bit of the nature conservation professionals who actually think this is quite a good thing, and you will find quite often in publications giving guidance to the management of woodland biodiversity, there's quite a lot of scenarios where people say doing nothing is the right thing to do to conserve these individual species. The problem is that for a private owner, traditional coppicing is really very risky. It relies on grants and it doesn't make you any money. Doing nothing makes you no money. So for the last 30 years, I've been developing on a significant part of this forest movement towards irregular high forest, exactly along the lines of AFI, with an understory, which in our case is pretty much dominated by birch and hazel. It's a slightly different understory, or souetage. And it looks very good. But there'd been no research. There'd been no research into what happens when you manipulate high forest. And so, again, I instituted another PhD, which actually was trying to answer this, provide some evidence. So the questions that we need to ask is basically how direct biodiversity output, and we've measured it in terms of actual numbers and species of birds, moths, and bats. So how does the actual amount of these vary with different structures fundamentally, and also between these three predominant management types: traditional coppice with very few trees, lots of souetage of hazel and birch, irregular high forest, or non-intervention. In terms of the government, they have a standard against which they judge the condition of these very important forests. So as long as I can deliver favourable condition according to their standard, then I'm okay. The main thing is, of course, how do we go into a management system which delivers biodiversity but means we also make a bit of money? So again, it's the same estate. Again, we've got this very wide range of structural diversity, which means that it's easy to set up a large replicated experiment. As I said, we've used birds, moths, and bats as the vectors to measure the biodiversity output. We started off with 300 sample points across the whole range of structural variation. Each one of those sample points had 2 years of bird density measurements in the spring and the summer. We then took 120 of the 300, which were clearly assignable either to irregular high forest, coppice, or non-intervention. And we did very detailed moth surveys. We did 700 moth surveying events, 35,000 registrations of individual moths. And then we did bat monitoring using acoustic devices. That's been completed a couple of years ago. The peer-reviewed papers are being produced with regard to the basic results as they relate to the three management types. There's a paper on birds and a paper on bats produced. There's a couple more to be produced, and then a congruence paper which tries to explain these differences by using all the covariates, because again, we've measured lots of structural parameters within the stands and soil and climate. It's worth saying that we think that the density of the souetage is actually a pretty key element in delivering reasonable amounts of biodiversity. So I'm just going to go very quickly, and we haven't got to very quickly, just give you some results regarding to the birds and bats. You don't really have to, you won't be able to read these things, but just to say that the left-hand side is the bird densities in the spring, the right-hand side is the bird densities in the winter. And the species down the left-hand side, and the 4 columns is coppice, irregular, limited intervention, and in this case we were measuring the whole of the structural variation, so we've got transitional stands between coppice and irregular. And the green highlighted entries are where there's a statistically significant pairwise comparison. So basically it means that where you've got a green, that particular management type showed a statistically highest amount of density. Now, a lot of them are in irregular, but it's worth saying that for certain key species, there are species, particularly the warblers. So the second one, the warblers, the grasshopper warbler and garden warbler, they both are very associated in most literature in the UK with these very intensive coppice systems. And the normal people will say, you cannot get these unless you do this coppicing. It turns out, though, that yes, they are the highest percent, you get the highest densities here, but if you look across to irregular, there's still very significant densities in the irregular as well. So, and the same with some of the limited interventions. There are a few species which are more common in the limited intervention, but you still get very good populations in the irregular. And there's one particular species, which is this one here, which in English is called a marsh tit. Now again, because we've got this catastrophic decline in biodiversity, there are certain key species which the government really hold on to as icons of decline. And within the birds, marsh tit is the one. And in the best developed irregular stands with the right amount of suetage, we've recorded some of the highest densities of marsh tits ever recorded. So this is actually a major result. And what this shows is, and that's not to say that we don't want some coppice and we don't want some limited intervention, but it shows that if you actually manage most of your forest productively as a regular high forest, you will actually end up generating more biodiversity than either going to coppice or limited intervention. And this is really quite a major result. The papers that are already published are available on Select4. I'll give you a reference at the end, so if you're interested, just go on to our website and you'll be able to read the papers. So just quickly on bats, and it's the same thing. It's actually even a bit more obvious in terms of overall bat activity, significantly higher activity in irregular compared to limited intervention. Because again, most received wisdom in the nature conservation world would say that limited intervention is the best thing for bats. It's not true. When you actually try and find out what evidence a lot of this received wisdom is based on, you find it doesn't exist. And if we look at bat richness, we've got the same scenario. The woodland specialists tend to be more dense in the irregular. And it's worth saying, with the birds, that the woodland specialists particularly have higher populations in the irregular. And again, this is the individual species, and you can say this is even more positive for irregular compared to coppice and limited intervention. And again, we have another one, the equivalent to marsh tits in bats is barbastrelle. I think in French it's barbastrelle? Yeah. And again, barbastrelle, we have high densities in irregular. So again, a really positive result. There's the other paper that's already published. So if you're interested in reading those, just go onto the Select4 website and follow that trail, and you're very welcome to read them. Okay, thank you very much.